Okay, this is problem number 2. It says the function is defined by, and they give it to me, it's a logarithmic function. It's pretty complicated. They say it's positive x. That's good, because it makes it easier for me to handle, and x is not equal to 1. You may wonder why they're giving these conditions, because they want the log to be a real number, and they don't want to be dividing by 0. They want me to go on to show that the natural log, when squared, is equal to 1. I'm sorry, when the natural log of x is squared equals to 1. We'll talk about this in a moment. Both f of x equals 0 and f prime of x is equal to 1. So I want to go to the whiteboard and see if that's true, by the way, all right? And then when I do that, we'll look at those integrations they have down over there, and we'll talk about what parts. So I'm going to do this in 3 parts. The first part is just to maybe think about this a little bit, and then I'll come back to these 2 over here, one step at a time, all right? Let's go to the whiteboard, and we're on problem number 2. And number 2, I'm given a function, f of x, and f of x is equal to 1 minus the natural log of x. That's going to be squared, and then this thing all gets squared over here, and it's going to be x ln x. All right? So they also said that, x greater than 0, and I'm glad they saw that, because the logs are going to be real numbers now. They also said x is not equal to 1. All right? And that prevents division by 0. All right? So this is the domain of the problem. That's pretty simple. Now, they said when, so when the natural log of x squared is equal to 1, that we get two things happen, by the way. We get that f of x would equal 0, and we get f prime of x is equal to 0. Let's go through that and see if that's true, by the way. All right? So let's write this down. And how do I do that? I guess I got to plug something in, right? So, when this is true, I could write down f of x, right? What's f of x going to be equal to? Well, 1 minus, well, that's easy. That's just going to be 1, right? And because they told me that. They told me the natural log of x, when squared, would be 1. And this would be squared. And then I'm going to say x. I don't even really need to know what x is at this point. But I got to be honest with you, I'm wondering if the natural log of x when squared is equal to 1, what would the natural log of x be? It would be plus or minus 1. And what would this give me over here? This just gives me 0. So this has been verified, by the way. All right? Now, I don't need to know what x is, but if you want to know what x is, let me should write that down, by the way. So the natural log of x could be equal to 1. The natural log of x could be minus 1. And what would that tell me? This would tell me x is equal to e. What does this tell me? X is equal to 1 over e. All right? But I don't need to know that, by the way. I know this is equal to 0. Now, I got the derivative over here. And the derivative always like, what are you going to do about that? I guess I got to write something down, right? I guess I write the derivative down. And the derivative, I'll be honest with you, it looks like it might be a nasty derivative. All right? So I'm going to write this over here, f prime. Let me write f of x down again. And f of x is going to be 1 minus the natural log of x, that whole thing being squared, and then x ln x. And again, it really does look difficult. Now, so one thing you could do, again, let me point this out again. X is greater than 0, and x is not equal to 1. So let's put the derivative down. It really does look nasty. Square the bottom. That's going to be x, natural log of x. That whole thing is being squared. Take the bottom to the top and multiply it by the derivative of the top. You know what? I copied wrong. Like a nested square. All right, let's do that. 2, 1 minus the natural log of x squared, reduce the exponent by 1, so it's 1, times the derivative of the inside. Wow. That's going to be 2, I'm sorry, it's going to be minus 2. Natural log of x, chain rule, times 1 over x. Okay. Minus the top. And again, this looks really nasty. Times the derivative of the bottom. I can jam that in there. I really mean that. So that's going to be, let's see, x times 1 over x plus ln x. All right, I got to clean this up. So f prime of x, on the bottom you can get x, ln x squared. That's not so bad. Let's do the top. And I'm looking at it, and I'm going to do the number first. I do see minus 4. I'm going to say I see an ln x squared. Okay? I see an x. I see a 1 minus a natural log of x squared. Oh, you know what? The x disappears. And why is that? I'm seeing this over here. So let me get my eraser out and erase this x, by the way. All right, and go back. Did I account for everything? I think so. Let me go to the next term. And next term, I'm going to write that down. It's going to be minus. I get 1 minus the natural log of x squared, 1 plus the natural log of x. Let me see if I got everything down. It doesn't really look that nice, does it? You know what I'm going to do? I'm going to factor it. So f prime. I'm trying to make it nice and compact, then I'll get back to their question. So I'm going to say this factor is common to both of those terms. Right, I see it 2 places, by the way. I'm going to pull it out. So I can put 1 minus the natural log of x squared times, we can get minus 4 natural log of x squared, that's done, minus 1 minus the natural log, yeah, let me go backwards. Really nasty looking, isn't it? Squared. And then 1 plus the natural log of x. I gotta close that out too. This over here. Really does look nasty, doesn't it? You know what I'm gonna do? I'm gonna continue to rewrite it. F prime of x. On the bottom you get x squared, ln squared. I'm gonna do the top. And that's gonna be 1 minus the natural log squared. Then you're going to get minus 4. Well, you know what? Let me just see if I got that. You know what? I think I made him. Yeah, no, minus 4. Natural log squared x minus 1 minus the natural log squared x 1 plus the natural log of x. Square bracket over there. I got the derivative. What was their question though? Let me go back and look at it. And they said something. And what did they say? They said that f prime of x should be equal to 0 when the natural log of x when squared is equal to 1. And I want to point out the natural log of x is really just this over here, all right, when you square it, all right? So I think I can write this down now. So f prime of x when, this would be 1 minus 1. Well, you know what? It's going to happen. I'll tell you why. just looking at this thing over, the first factor is 0, so it's going to multiply out to 0, by the way. But let's go keep going through it. What do you do there? This would be 1 minus, this would be 1 minus 1. What's over here? 1 plus the natural log of x. Let's not worry about what that is at this point. But I do know this evaluates to 0 at this point. And why is that? That factor is equal to 0. All right? So I'm done with this. We did the first part. Let me see if there's anything else they said there. And I do have to be careful about that. Let me look at what they said. I got that part. And let's see what else they said. No, that's all done, by the way. And we're good to go to part A and part B, which depends on looking at these functions f, which is an integration problem, all right? And maybe I should write that down. So f of x is equal to, well, two different things. It's equal to 1 over e to x f of t dt. And let's see, this is going to be e x f of t, whoops, sorry about that, dt. This is for when x is between 0 and 1, and this is for when x is greater than 1, all right? So I want to point out what f is again. F of x is equal to 1 minus the natural log squared of x, quantity squared, over x, ln x. The derivative, I'm not going to write that down again unless I really need to, but there is a derivative thing over here. What do I know when? Let's see, the natural log squared of x, when this is equal to 1, that means x is equal to e, we just did this before, or x is equal to 1 over e. When this is true, both f of x and f prime of x would equal to 0. So when x is equal to e, or 1 over e, we would get that condition met. All right, we'll go to part A and part B now. Thank you.